We are over here studying relation between time versus temperature. First, be clear with the symbols. When we use small, we call it as time, and here it will be temperature. Okay, now what are the connected formulas? Let us work upon them and then we'll just create a relation for time and temperature. So we have one formula, Q is equal to MC delta T. Delta T means change in temperature. Okay, change in temperature, for now we can just consider it like a temperature only as a variable, but to be very precise it will be written as T2 minus T1. Okay, right now we'll just avoid that thing because we need to just analyze the formulas. And then Q is energy. It is some kind of heat, so it can be written as energy. Now energy per unit time is power. So power times time can be written as energy. Okay, time goes on the other side. We can write Q is equal to PT. There's a reason, we'll just discuss soon. Now, if I replace this Q value with PT, I have PT is equal to MC delta T. As I was saying that delta T will be T2 minus T1, but just as an indicative variable, we can consider it as capital T. Now here you have to understand that the graph is made between T and T, temperature versus time, where temperature is on the y-axis. So if I want to make sure that I convert that in the form of y is equal to mx, then I have to make this capital T alone. I have to make that as a subject. So I'll write capital T is equal to P over mc times T. If I compare that thing with y is equal to mx, where this m is not same as this m, in y is equal to mx, m is just a gradient, while over here this m is mass. Okay, so if I just compare this whole thing with y is equal to mx, then I can say that gradient for this graph will be P over mc. Now I don't have to remember it as a formula, but I can at least say that gradient, which I'm taking it as G, is inversely proportional to specific heat capacity. Because power will be constant, mass of a substance will be constant, only specific heat capacity will be changing as per the substance. So gradient is inversely proportional to specific heat capacity. Now, if we look at the first line is more steeper and second line is less steeper. We don't have to calculate any of the values. We can just work on the basis of steepness. So if first line is more steeper, it means gradient value for first will be higher. If gradient value for first will be higher, then C value for that will be lower. So the conclusion is specific heat capacity for solid to liquid or for ice to water is less as compared to specific heat capacity when it is converted from liquid to gas. Over here, gradient is less, so specific heat capacity will be more, and that is how we can compare using the formulas. So now you can just check it out. If there is any doubt in understanding the formula, that we can discuss again.